Hey everyone, my name's Riley Meek. I'm here with Sugarhouse Aerospace. We are a company that focuses on providing consumer-priced access to space. So we're going to start today off with a bang. Yesterday, we were up in Heber City testing our rocket motor. Martin Fry actually was the one that helped us get the test site for us, so we're really grateful for that. This is the rocket motor that will power our test vehicle that will launch on May 18th. So let's get the countdown going.
5, 4, 3, 2, 1.
We also have snow removal services if you're looking for that. So before I jump into the tech of Sugarhouse Aerospace, let's talk about a question that's really important to me and should be important to you. Why does space matter? A lot of people here in this country and throughout the world think that space and space technology is a waste of money and a waste of effort. They don't realize, though, that there are technologies and other things that they use every single day that depend on satellites and other technology in space. Part of the reason there's this big confusion about space technology is there's such a large gap between consumers, or people on Earth, and technology in space, both literally and figuratively. So we aim to lower that by giving people the opportunity to put things in space. We think that if we can give people the opportunity to put things in space at a lower cost, technology will develop faster, and not only will technology in space develop faster, but also here on Earth. So right now, if you wanted to put something in space, your cheapest option is $30,000. That is a payload that is a third the size of an iPhone. It's tiny. So you pay the price of a brand new Model 3 to put a third of your iPhone in space. It's expensive. Now if you wanted to put something in space for 5 minutes, it would actually cost you $350,000, the price of a house. Now why is there this huge difference? Here, at $30,000, you're only paying for a piece of a ride. You're not paying for the entire vehicle. You're paying for your ride. Here, when putting something in suborbital space, or space just for a few minutes, you have to pay for the entire vehicle. Rideshare doesn't exist. So with Sugarhouse Aerospace, we're trying to introduce rideshare to the suborbital market. So instead of paying $350,000, if you were to buy the entire vehicle from us, it would actually cost $150,000. And if you wanted to buy just a seat, for as low as $1,000, you can put something in space. The reason this cost comes down so much, first with the vehicle, is because we manufacture, we test, we design everything in-house. The aerospace industry has relied heavily on markups, outsourcing. We're cutting all of that away so that you don't have to pay for it. But in order to reduce the cost down to $1,000, we're introducing something new. Meet Sugarhouse One. This is our vehicle, our launch vehicle. What's different about this one compared to others is that it is designed specifically for small payloads. Previously, you would have a vehicle that just has a tube on top. You fit everything you can inside of that tube, you launch it to space. This one has these little trays. They're designed to carry small payloads, picosats or femtosats. They're 10 by 10 by 2 or 10 by 3 by 1. They're these small little payloads that universities right now, they depend on this standard for all the other things they're launching. With us, you can launch a femtosat for $1,000 or a picosat for $5,000. But if you wanted to buy the entire payload space, like I said earlier, it's $150,000. So this focuses primarily on 3 different markets. First, we have NASA. NASA will give out grants every year. They spend $50 million allowing small businesses, universities, and other educational institutions to put things in space. So you apply for a grant, you get the grant. That pays not only for the launch, but it also pays to develop some of your technology. Education, we're focused on the universities that don't get those grants, giving them the opportunity to put something in space, even if they aren't getting outsourced or outside funding. And eventually, we'd like to open up space to the average consumer, someone like you. You could go online, purchase a package to make your own satellite, send it to Sugarhouse Aerospace, and put it in space. For 2019, the first quarter, we're finalizing our technology development. You saw that rocket motor test for yesterday. That rocket motor was that test was the last one in order to validate our propulsion for the launch in May. On that launch, we will have 2 customers launching payloads into space, one doing microgravity research and another doing some educational payloads to send out to local K-12 schools. Quarter 3 will be spent developing our space vehicle, or the workhorse of our company, and in December, on December 14th, we will launch our first vehicle into space. So that's us. We're super excited to be able to open space not only to those that have deep pockets, but to everyone, especially students and small aerospace companies. Thank you.
Any regulatory issues with launching stuff into space?
You just have to have a good relationship with the FAA, which we do. We work with Spaceport America. They are a spaceport in southern New Mexico. They are one of 2 places in the country where airplanes are never allowed to fly over. The only other place is the White House. So if you work with them, they do all of the work with the FAA so that you can launch easily. When it comes to propulsion, we use a non-regulated propellant. It's not regulated by the ATF as of 2007 because it's not dangerous compared to other things. So.
Expand for me a little bit about your manufacturing processes, where you're at, and what you anticipate to accomplish in the 3rd quarter.
Yeah, so right now we have been doing a lot of our testing and manufacturing here at BYU in the machine shop. Right now we are looking to raise money so that we can build our own machine shop. We have a shop up in American Fork where we do all of our propellant development, but eventually we'd like to have our own machinery up there so that we can do everything. Right now everything can be built on a lathe and a CNC mill. If we have those 2 machines, we can build the entire rocket. And that is enough to not only develop 1 rocket for this year, but the 4 rockets that will launch in 2020 as well.
Riley, describe some of your theoretical modeling and engineering that's gone into some of this.
Okay. One of the biggest things is the deployment system. As we were talking about earlier, having multiple seats so that multiple payloads can fly. Normally, every payload has to have the same flight if there is a ride share. We are doing a lot of work to be able to create a payload deployment system that allows every customer to choose what their flight will be like. They decide if they deploy into space, if not. If they do deploy into space, they can decide when. Every customer has access to space without having to be left into space. They can come back safely with us. In order to do that, we've been doing a lot of work with Kevin Cole in the mechanical engineering department. He's been helping us to develop the software that will control all of the hardware that goes into that. On the propulsion side, we had to do several different motor fires preceding this one that you saw that was yesterday in order to characterize the propellant or understand how does the propellant react to different pressures inside of the pressure chamber. And using that, now we're within 1% accuracy on every test after doing a ballistic simulation.
Can you land the rocket and make it recoverable?
Yeah, the entire rocket is recoverable and 90% of it is reusable. So it's designed so that cost is as low as it can be, not only for us. That means less manufacturing for us, but it also means less cost for the consumer.
What's the market? What's the market opportunity? The size of the market? What's the demand for this kind of thing, and the dollar amount that you're looking at?
Yeah. So right now, like I was saying, NASA spends $20 to $50 million every year on flights like these. So they will pay companies like us. There are 2 other aerospace companies that do the same thing. They will pay our company to launch their payloads into space. We're getting certified with NASA in December so that we can start launching their payloads. But we see the real market in the educational technology market because right now they don't have access to space. They can't just buy a slot on a rocket and launch it into space. It's just not an opportunity. So there are 90,000 schools that have $250,000 to spend each year on technology. We're hoping that we can get $5,000 from each of them to bring in $20 million of revenue annually with our launches.
how do you break through the credibility barrier? There's this random variable guy named Musk, and he captures a lot of attention. And certainly with NASA, but how do you break through it and get people to really get on board, really figure it out?
Yeah. So one of our big things, something that we're trying to change, we don't want this to be just like every other space industry where it's far away. We're trying to increase our social media. Our first big social media drop will be today with the test of this rocket motor. We want this to feel comfortable. We're going to be visiting schools. We're going to be inviting schools to launches. We want this to be an everybody thing. Anyone can have access to prices, which previously hasn't existed in the space industry. We just want it to be comfortable and give everyone the open opportunity to ask questions and be there and to be a part of it.
Thank you, Sugarhouse Aerospace.